Hello everyone. I'll be talking about IoT in agriculture, smart farming, its key technologies, and a machine learning implementation. A brief introduction. Earth's population will double in 2050, and this would increase the demand for food by 50% and livestock by 70%. This would require new methods to provide food above historic levels. One of these ways is by using IoT, the Internet of Things in agriculture. What does this mean? This refers to the network of physical objects such as sensors and actuators that are connected over a network and used for agricultural related purposes. The emergence of these has led to new fields such as precision agriculture and smart farming. Precision agriculture is the science of increasing crop yield and assisting management decisions through the use of high-tech sensors and analysis equipment. Smart farming is an extension of precision agriculture that uses IoT and includes all the steps from precision agriculture, but it uses data for analytics, storage, and assists the farmer in making better and more sustainable decisions. What are the key technologies in IoT? These are the ecosystem, cybersecurity, and big data in smart farming. First of all, we'll talk about the IoT architecture in a smart farm. This is fundamentally made up of three layers. These are the IoT device layer, the network layer, and the application layer. In the IoT device layer, it's divided into the sensors that measures the temperature, the humidity, and the soil nutrients. And on the other hand, we have the vehicles, the unmanned aerial vehicles that go out to scan and scout for any predators or pests on the farm. And this informs the unmanned ground vehicles to either go and harvest or spray fertilizers or pesticides if need be. The next layer is the network layer. This is where communication between these devices happen, and it depends on the size of the farm and the proximity of different sensors. As seen on the graph here, the protocol transmission rate and the propagation distance. For short range, Bluetooth and Zigbee is usually used. For longer range, Sigfox and LoRaWAN are usually used. And for livestock monitoring, NFC and RFID are commonly used. It's worth noting that on a large farm, all these networking protocols are being used. The common network topology used is star topology, and a mesh topology is on the rise that utilizes machine-to-machine communication. Also, blockchain technology for edge computing is on the rise. Also, in the network layer, it comprises of a network of nodes, and when these nodes are above ground, they are called terrestrial wireless sensor network. And when they are below the ground, they are called wireless underground sensor network. And how these underground sensor networks communicate with the nodes above is by using surface sync. The applications layer is the layer the user interacts with and is commonly referred to as the smart layer. This is where data is collected and analyzed. AI technologies such as machine learning are being used to help farmers make better decisions. The communication protocols commonly used is MQTT, and it is used to monitor and provide intelligent recommendations for controlling system throughput. Another key technology is cybersecurity. As more and more IoT devices are being used on the farm, cybersecurity is becoming an essential component of smart farming, as it is needed to protect and secure the farm. Maximum security, the smart farm should be safe from data attacks, which include falsification of data. It should also be safe from network attacks, which is commonly the radio frequency jamming or DOS attack. Also, the supply chain attack, and lastly, other forms of attacks such as cyber terrorism. Another key technology is big data analysis. This technology is used to detect patterns and trends from vast amounts of data collected from sensors around the farm. Computation of this data is usually done in the cloud, and by leveraging big data analysis, farmers can predict future needs of their crops and adjust production accordingly. Big data analytics also helps farmers make better decisions on when to harvest, what fertilizers to use, or how much water is needed for optimal crop yields. This inspired me to make a machine learning prediction of my own in which I got data from cargo to predict the best crops to plant based on data that was gotten from IoT sensors on farm. These sensors capture data such as nitrogen, phosphorus, potassium, temperature, and they recorded these while different crops were being planted. Before starting off the machine learning, I did a quick exploratory data analysis, which showed that nitrogen had the most effect on all the crops on the farm. Fortunately, there were no missing data. As we can see, the machine learning outcome had 100% accuracy and just 1 point was wrongly predicted. In conclusion, the model's perfect accuracy score demonstrates that machine learning can be used to determine the optimal crops to plant based on sensor readings. However, there are still some challenges in this space that needs to be addressed, such as the battery life of IoT devices, reliance and reliability of cellular network connectivity, security of data, data analysis and management. As a solution, government should focus on developing innovative technologies and solutions to tackle these challenges. Furthermore, standardization must be adopted for various devices and systems to communicate with one another. With the right technology, the benefits of IoT, such as improving crop yields, can help farmers become more productive and thus increasing profits. Here are my references, and I would like to say thank you all for listening.